So yeah, moving on to, oh yeah, here's the references from that section. All done in art style. Section 3, covering lobes, pleural membrane, thoracic cavity, and visceral pleural fluid, and intercostal muscles. Okay, so lobes. The lungs are divided into lobes. The slightly larger right lung is divided into three lobes. The superior lobe, located at the top of the right lung, the middle lobe, located in the middle of the right lung, and the inferior lobe, located at the bottom of the right lung. The left one is only divided into superior and inferior lobes. Each lobe receives air from its own bronchioles. It is separated by connective tissue. The lobe's function is if a part of the lung is infected or another lobe is infected and it needs to be removed, then the rest of the lobes can work normally and it won't drastically, the subject can still breathe efficiently. Moving on to the next. Pleural membrane. The pleural membrane is a layer that lines the chest wall and is also known as the parietal vessel. It is also known as the parietal pleura. The pleural membrane helps to keep the two lungs away from each other and keeps the chest cavity airtight. So, if one lung is punctured and collapses due to an accident, the other pleural cavity will still be airtight and the other lung will work normally. The pleural membrane is sensitive to pain. Moving on to the next one. Thoracic cavity. The thoracic cavity is basically the chest and involves everything between the neck and the diaphragm. The thoracic cavity has three parts, the mediastinum and the two pleural cavities. The mediastinum is home to the heart, trachea, and some other structures. The pleural cavities are on either side of the mediastinum and contain the lungs and pleural linings. The lungs are surrounded by two membranes. The inner pleura is called the visceral pleura. The visceral pleura lines the outside of the lungs. The visceral pleura is insensitive to pain, unlike the other layer of the pleural membrane. The main function of the visceral pleura is to separate the two lungs and keep them airtight. This is a special point in an accident, for example. If one lung is punctured and damaged, the other one will be fully functioning. Pleural fluid. Pleural fluid is found between the two layers of the pleural membrane. The space containing the fluid is called the pleural cavity. Pleural fluid acts as a lubricant during respiration and stops the two pleura from running together. Internal and intercostal muscles. These muscles are found between the ribs, and there are two kinds, the internal and external intercostal muscles. The internal intercostals, found inside of the rib cage, extend from the front of the ribs and go around the back, past the bend in the ribs. The external intercostal muscles, found on the outside of the rib cage, wrap on from the back of the ribs to the end of the rib at the front. During inspiration, breathing in, the external intercostal muscles contract, and the internal intercostal muscles relax together. With the movement of the ribs and the thoracic, this increases the volume of the thoracic cavity. So yeah, again there's the references. And moving on to section 4, it's actually section 4, I don't know why it's section 4. Okay, so section 4. Covering gas exchange mechanisms of breathing, lung volumes, and control of breathing. The first one is gases exchange. The exchange of gases between air in the lungs and blood, and respiring tissue and blood. Gas exchange is the exchange of gases between air in the lung, tissue and blood. The essential feature of gas exchange is that oxygen is absorbed into the body, and carbon dioxide is the waste product of respiration and is eliminated. Efficient gases exchange is essential for health and fitness. If it is impaired in any way, for example, because the lungs are clogged with soot from tobacco smoking, then the ability to exercise is greatly reduced. But obviously having good gases exchange will help most of our because it means you get oxygen to his working muscles to provide them with the energy they need to perform and obviously to break down that lactic acid. Mechanisms of breathing. The process of breathing refers to when the lungs take in oxygen and expire carbon dioxide. The cycle of breathing happens in 3 phases: inspiration, expiration, and pausing. Inspiration is when the intercostal muscles contract, so this means that the ribs and sternum move upwards to allow for more air to be taken in. Also, the width of the chest increases. Again, this is to allow for air to be held. The diaphragm also contracts, which means that it doesn't, and the depth of the chest increases. Also, during inspiration, the lungs expand to fill the newly expanded thoracic cavity. Now, and then during expiration, the external intercostal muscles relax, which means that the ribs move down and squeeze the air out of the lungs. Also, the diaphragm relaxes, so the capacity of the thoracic cavity decreases. The air is squeezed out of the lungs because the body needs to get rid of CO2, which is a waste product during respiration and breathing. Okay. And this will help Mo Farah because it means that he get oxygen to his muscles effectively and quickly. And again, I keep saying in this video, the reason he needs oxygen is to provide his muscles with energy and to break down the lactic acid because he's working aerobically. Okay, on to lung volumes. Lung volumes are the amount of air inhaled, exhaled, and stored within the lungs at any given time. Now, tidal volume is the amount of air which enters the lungs during normal inhalation and at rest. An average tidal volume is around 500 milliliters. The same is exhaled. Now, residual volume is the amount of air left in the lungs following a natural exhalation. There will always be a little bit of air remaining to prevent the lungs from collapsing. Vital capacity is the most amount of air you can exhale after taking the deepest breath you can. It can be up to 10 times more than you'd normally exhale. Now on to controlling of breathing. Controlling of breathing. Breathing rate is mainly regulated by neural and chemical mechanisms. Chemical control is done by chemoreceptors in the brain and heart that sense the amount of oxygen, carbon dioxide, and acid present in the body. As a result, they regulate the respiratory rate and compensate for any disruptions in these chemicals. Too much carbon dioxide or acidity or too little oxygen causes the respiratory rate to increase and vice versa. There are 2 neural mechanisms that control respiration, one for voluntary breathing and one for involuntary breathing. The voluntary impulse originates in the cerebral cortex region at the brain, and the automatic impulse is from the medulla oblongata. Moving on to the next one, the journey of an oxygen molecule through the respiratory system. Okay, following the journey, I'm going to describe the journey of an oxygen molecule in the body. We start off when the oxygen molecule is inhaled through the nasal cavity and then goes down the trachea and into the bronchioles, and then into the alveoli where oxygen molecules get diffused into the bloodstream and then get picked up by the hemoglobin and the red blood cells. The now oxygenated blood gets through the arteries and then the capillaries where the oxygen diffuses into the muscles to help it work, and obviously the cell that's lactic acid. And the deoxygenated blood then goes to the heart to then be pumped back around to the body where cycles happens all over again. Okay, and then there's your references, and that is the end of my video.